أنا le représentant du club Irizi. Soumana Abdou Amadou est le
We are live.
représentant. On est live?
Ah,
Ah, ok.
yeah.
Donc, salam alaikum. J'espère que vous allez bien. C'est bon. Salam alaikum. Bon, j'espère que vous allez bien, que kulchi ouadak. ما عادش واش نبداو دابا نيت ولا نشوفوا. Bon, je vais commencer par me présenter, Beda. Je suis Elfid Faisal, étudiant en deuxième année cycle d'ingénieur Irizi. Irizi, c'est ingénierie en réseau informatique et système d'information. Euh, et je suis le représentant du club Irizi. Juste une petite définition de c'est quoi le club Irizi. Bon, le club Irizi, c'est le club dans notre filière, mais puisque c'est le seul club d'informatique FST de Marrakech, on essaie toujours d'organiser des événements l'informatique. Oui, on essaie de partager notre passion, qui est l'informatique, et, et aussi trouver des formateurs compétents pour animer et profiter des formations. Euh, pour cette formation, j'ai à mes côtés Monsieur Soumana Abdou Amadou, qui est mon camarade de classe, et le Google Developer Student Club Lead de la FST Marrakech. Bonsoir Amadou.
Et bonsoir tout le monde. Merci Monsieur Faisal de m'avoir donné la parole. Je m'appelle Soumana Abdou Amadou. Je suis élève ingénieur en réseau et système d'information dixième année à la faculté des sciences et techniques de Marrakech. Je suis également développeur student club lead de la dite faculté. Je tiens à souhaiter la bienvenue à tout le monde à cette session de formation et de partage. Et je donne la parole à mon collègue, Monsieur Ali Kiyati.
So, hi everyone. So today we'll do an introduction to machine learning. First, I will present myself. أنا خياطي علي. I'm a student engineer second year في إريزي. and I'm organizer at the إريزي club. Bon, كيما كتعرفوا ماشين ليرنين ولا معروف بزاف هاد الايام ودرنا واحد سيرفي où la plupart بغاو machine learning. Donc pour cela on a décidé de commencer هاد العام بواحد une série de formations في machine learning. داكشي علاش اليوم معنا notre expert في deep learning سارة العاطف. Donc vraiment j'ai assisté بزاف ديال les formations ديالها soit مع GDG ولا avec DFC Casa و vraiment استفدت منها بزاف. داكشي علاش حتى نتوما بغيتكم اليوم تستافدوا منها كما استفدت منها انا. Donc Sarah, can you present yourself?
Yeah. So شكرا بدأ على the wall praise. So سميتي سارة العاطف. I am an engineer from إنصاف الجديدة. My field was computer science and emerging technologies engineering. Or my specialty is big data engineering. But I hate big data. And but what is more interesting to me is machine learning, and more specifically deep learning applied to computer vision. So today I'm going to present to you what machine learning is all about, and we will see a simple example, and I hope it will be the punch you needed so you can get started in the field. Thank you for having me.
Great, great. We are honored. Thank you very much.
Yes, we
Thank you.
appreciate that you are with us today.
Thank you.
So هاد اليوم الفورماسيون غتكون for everyone. I think it's just introduction. ماشي بالضروري تكون في الاي تي ولا في الانفورماتيك ولا بيج داتا or something. I think everyone يقدر يستافد من هاد اللايف اليوم. Donc I think we're gonna go.
Sure,
start?
let's get started.
Okay.
Okay, let me share my screen. Can you please add it to the stream?
Ali?
Thank you. Okay. So I have one question before I get started. Do we have foreign people that are watching this? Because, you know, like if we have foreign people, it has to either be French or English, not Darija.
Yeah, we have foreign people, but I think we can go with English.
All right, so I will go with English. That is great. All right. So hello, everyone. Like I told you before, I'm going to present machine learning to you today. Like I'm just going to present it to you briefly, what it is, how you can get started in it, and all of that. All right. So like I told you before, I am Sarah Latif, a machine learning or deep learning engineer, whatever suits your taste. I know both of them. I can even be called a data scientist or big data engineer. So I am part of all these amazing communities that helped me grow up as a machine learning engineer and keep giving me opportunities to know more and to grow up more. All right. So what is machine learning? So like there are lots and lots of definitions, but the one I really liked because it was one simple and second, it had all parts from the different definitions out there. So let me read it out to you and we will try to dissect each one of these words alone. So according to emerge.com, machine learning is the science of getting computers to learn and act like humans do and improve their learning over time in autonomous fashion by feeding them data and information in the form of observations and real-world interactions. So the keywords here is learning. So what we are doing with machine learning is to teach how computers how to learn so they can act like us humans, and so also they can improve their learning over time. So not only learn, but they have to improve how they learn. Obviously, in autonomous fashion, which means we don't want to get involved in their learning process like as a human do. Like, for example, a teacher teaches you something, like a lesson or how to do something, but later on you won't have your teacher helping you. You will be doing the task alone. So this is what we want from our machines to be able to do. And this is what we are trying to accomplish through machine learning. Okay, so usually when a teacher is actually teaching you, what are they teaching you? Like, how are they doing it? They try to give you information. Like, for example, they explain a concept. Like if it's math, for example, let's say they are trying to teach you how to multiply numbers. They're going to teach you all there is about multiplication. They will tell you, for example, this number multiplied by this number usually equals to this. How do we do it? Like, how do we know it equals to this? How did we come up with the whole multiplication and all of that? They try to teach you as much as you can so that later on you can learn by yourself and apply by yourself without needing your teacher to assist you. If you have any kind of questions, feel free to interrupt me at any given moment. All right. Now, is machine learning the only thing that there is out there? Of course not. So everything started thanks to artificial intelligence. So there is a big dream that scientists had always wanted, was to create an entity that resembles humans, face, actions, and all of that intelligence. But even more, they want someone who is like better than a human, like a highly intelligent being. All right, so that is what artificial intelligence goal is. We're still not there, but that is what they want. That is the crazy dreams that they're trying to realize for now. Okay, so this is like the overall goal. But when someone tells you artificial intelligence, and we'll speak about machine learning and deep learning later on, what they mean by artificial intelligence is that it's a technique which enables machines to mimic human behavior. Otherwise, it's like something, for example, let's say, for example, you want to cook. You want to cook a simple dish. What do? Like, you bring the ingredients. You need to know, for example, how much you need from each ingredient. You mix them together, and here is your dish. Great. Now we're going to teach the machine the same thing. You're going to tell it, for example, if we want to, for example, do a spaghetti dish, we need the spaghetti, we need the sauce, and we need this and that. And you mix this with that. Like, let's say, for example, you're going to cook, of course, the spaghetti first, and then you will add the sauce later on top of it. So this is how we teach the machine. What we want is the machine to be able to be a cooker like the human does. So we teach it what to do. This is a simple one. This is a simple task. And it's replication. You didn't teach it anything too troublesome. Like, for example, if you were to ask the artificial intelligence to solve an equation, I'm not talking about the simple, like multiplication and all of that. I am talking about huge equations. And usually, so far, we only had humans solving them. All right. If we were to want to go a bit deeper, what do we need? We need something that will learn from previous experience. To do that, we have machine learning. So the machine learning is a subset of the artificial intelligence that actually use statistical methods so that it can teach machines, and over time they improve from their learning. Now, what is the difference between machine learning and deep learning? So first things first, deep learning is a subset of the machine learning. But the thing is, in deep learning, we have more layers. Like we have an improved intelligence than in machine learning. Why? In machine learning, we still need humans to tell the algorithms what kind of features are important. Let's say, for example, I want to recognize humans in a picture. I will tell the machine learning, if you want to recognize humans, let's say, for example, humans have faces, they have two eyes, they have one nose, they have one mouth, etc., etc. So you're going to tell the machine this. But in deep learning, the model is the one learning what a human is. They will learn, for example, like I told you, the things like a human has two eyes, has, for example, one nose, one mouth, and all of that. It's going to be the deep learning model that is going to figure out that these are, like humans' characteristics. But in machine learning, you have to tell the machine what characteristics it needs to pay attention to. All right. Now, what kind of applications do we have so far, or where is machine learning involved? So, I am sure you have already heard about self-driving cars. They are used in trading. For example, like we call it forecasting. So trying to figure out what is going, for example, to happen in stocks later on. It's used in medicine for cancer diagnosis, pneumonia, and all the things that they need, to figure out, like finding out a certain disease, if there is a certain disease in a cell or in a chest X-ray array, all of that. Sentiment analysis, like it was used, for example, during the elections, to figure out, like, for example, who's going to win through public sentiments. Object recognition, recognize humans, cars, traffic lights, traffic signals, and all of that. And there are a bunch more applications as well. All right, so now that we understood what machine learning is, how can we get started in it? Perhaps you have already figured this out. We obviously need maths. As how do these algorithms actually learn? It's not magic, it's just a bunch of math. A bunch of functions that the model uses so they can update their learning. Statistics, because how are you going to generalize? Like, how do, for example, humans know that, let's say, for example, that there is a certain phenomenon, or how many people are affected? We just use statistics and probability to figure this out. So we do a number of studies. We try to see a sample, from a huge population. We study a sample, we see what is happening with the sample, and we try to generalize according to a specific, of course, conditions. Programming skills and thinking, of course. Like, we need to actually know how to code so you can tell the machine what to do. Business domain knowledge. Actually, it's not actually business domain knowledge, but it's more like domain knowledge. Let's say, for example, you're coding a machine learning model that is going to tell you if a certain cell, a human body cell, is cancerous or not. If you don't even know what cancer is, how are you going to know if your model is performing well or not? So you need to understand the domain you are applying these algorithms to. Data storytelling. All right, so you built your model and all of that, but at the end of the day, you need to communicate what you found out. So you need to learn how to communicate your results. So resources, like where can we learn all of this? So there are a bunch of amazing courses out online. Like, for example, Khan Academy has one of the best maths and stats and probability courses. There is specializations in Coursera. I'm sure everyone knows about the Andrew ones. So they are the best usually.
Yeah, sure.
All right, statistics. Well, my favorite one so far is Udacity's, but you can check the Udacity ones, the descriptive statistics, inferential statistics, but you can also check out the Khan Academy's one. Khan Academy explains everything step by step. Udacity does as well, but for example, it's more theoretical from Khan Academy's side, and Udacity tries to do between theoretical and practical. All right. So recommended books, because not everyone likes courses online. There are people who enjoy reading books. So you can, for example, start out with Python Data Science Handbook and finish on, not finish, but, like move on with Hands-on Machine Learning, Scikit-learn, Keras, and TensorFlow from Aurélien Géant. Everyone knows this book, and all the experts recommends this book. Like, all the experts I know, for example, when I ask them for what kind of book do you recommend to me? They're all like, Hands-on Machine Learning from Aurélien Géant. I'm like, all right, I know that book. I already read it. So this is one of the books that is always recommended. But of course, there are specializations, and like I told you, MOOCs, like Machine Learning RNG, like that was the first course I started with at least. Deep Learning Specialization from Udacity. It's a great, really, really amazing course as well, because it covers everything. And the Fast AI course is good as well, but they have a top-bottom-down approach, not the down-then-top like the other ones. All right, Of course, resources are everywhere. GitHub is one of the well-known. Kaggle is one for competitions and for learning as well. DataCamp is good when it comes to data science stuff. Machine learning as well, but they're really, really, really great when it comes to data science and how to manipulate data. Towards Data Science is a blog post. You can check it out along with Analytics Video is my favorite. It's where I go always to check out new stuff or even the old ones like algorithms. And even like when I want to understand something quickly, that's where I go. So Facebook Artificial Intelligence and Google AI, it is always great to keep up with great companies, what they're doing, especially when it comes to AI and their papers, research papers. So keep a track and an eye on research papers. All right, about storytelling. So my favorite course is data visualization with Tableau from Udacity, because it's a great way to learn how to do data visualization, and they take a lot of advices from Storytelling with Data book from Cole Nussbaumer Knaflik, which is a person from Google. And yeah, everyone is praising her for the way she does storytelling. So yeah. All right. Now, what is the typical business ML workflow? So each business has their own workflow, but like most of them agrees on these things. So the most important one is to understand your business needs. So if you don't understand what your business needs are, you won't be able to build a good machine learning model or a good product in general. So after actually defining, like understanding your business needs and defining the minimal viable product, of course, you need the data, because we can't train a machine learning model without the data. And you need lots and lots and lots of data if you want a good performance. So get data. Well, data in the real world is really messy, so it needs to be cleaned and pre-processed. So prepare your data, train your models, and after training your models, evaluate them. And it's a cycle. This is an iterative process. Like at any given moment, you can go back to a certain process and repeat it if something goes wrong. So after prototyping, of course, you're going to push your model to production so that your users can use it, productionize the model, deploy it, then make predictions. And of course, your machine learning model is in the wild and you don't know how it's going to act. That is why we always make sure to monitor the predictions that it is given, asking for feedback, and even retrieving the model and improving it over time. This is what we call measure. So gather and analyze insights, and you may even restart the process if something new comes up or something is missed. So you will have to go at a certain, like for example, in the repeat the prototype process, or even define again your business needs. Let's move on to the example. All right. So I'm just going to show you where you can find it. So I put it here in GIST, in GitHub. And if you want to use it, like go to Google Colab, click on File, open Notebook, GitHub, and simply copy paste this in here and click on Search, and they will directly open it up for you in a Colab notebook. I'm not going to open it as I already have it here. There's no need to have 1,000 copies. All right. So what are we going to do? I believe, like most of you already know what Spotify is, or any music recommendation system, like even YouTube is a video recommendation system. All right. So usually, what do these people do? Like in YouTube or Spotify, you have a huge list of songs for Spotify, or you have a huge list of videos in YouTube. Obviously, you're not going to be interested in all of that panoply. Like when you go there, if you don't have a specific idea in your mind, like you like a specific music and you're going to search for it, you will want it if there was a way for them to recommend something you think you would like. Usually, like most people, for example, when you go into YouTube, of course, not the first time, like the third time, they already pick up on your tendencies, like what you like. So they begin to recommend something you will be interested in. And you're always tempted to click on one of them. So this is like what we're going to see today, like something similar, not 100%. Okay, so the problematic here, like the business need, is for us to provide personalized recommendations. And what we want more specifically is to categorize all of that bunch of music that we have in our library. So what they did is that, of course, we have the data, like all the music that we have available. But another research group tried to find features, like specific features for this music, so they can classify them. That is why, so the research group is called the EcoNest. And what they did is that they give us specific features to these songs. Let me just show you what these actual features are. So something like acousticness, danceability, energy, instrumentalness, liveliness, speechiness, tempo, valence. So they can define the actual genre. All right. So for now, we have only two genres that we're going to concentrate on, which is hip hop and rock. So we have two data sets that we will be merging. So we have a data set that contains only the musics, like the music, and the other one contains the actual, features of that music. Like I told you before, this acousticness, danceability, and all of these features. All right, so we read the data. So we have the tracks, the music one, in a CSV file, and let's call them metrics or features, this danceability, acousticness, all of that. We have them in EcoNest metrics or JSON. Okay, so we're loading the data through Pandas data frame, and we're doing an info, a .info, so we can get general idea on the columns that we have, how much data, like how much tracks do we have. So we have 4,802 music track, and the number of columns, of course, are these here. All right, and usually you have to check out these kind of things as well, but for now they're not really interesting for us, but sometimes it's important to know about them. So you can know, for example, you have categorical data or integer data or float, for example, here, so you can do proper preprocessing later on. All right, so we usually use this head just to get a feel around the data. For example, showing up the first 5 rows, like here. So as you can see, we have track ID, acousticness, danceability. So they are I believe these are like coefficients. So I really don't know how they come up with these kind of things. So we would need to research more on them if we want to know. But remember the genre top, the one we are interested to figure out what it is. So this is what is important for us. So these track ID, acousticness, danceability, energy, whatever, are features of the songs that we have. And the label, which is what we are interested in figuring out, which they called categorization, or call it a classification between a certain music and another. So this hip hop and rock is the one we are trying to figure out from this data. All right. So one of the things that we do usually, like if your data is clean, of course, if it isn't, you will have to clean it. So cleaning the data means getting rid of noise, like errors, things that makes no sense are called outliers. So we have to get rid of them. And sometimes, like for example, someone did an error in some kind of number or something, so we try to fix it. So that's usually what cleaning is all about. All right. Now, one of the things we do is we study the relationship between each of these features. So these are either called, normally they are called features, but if you want, you can call them columns. But these are features. So the features of each song. I hope it's clear. If you have any kind of questions, please drop them. All right. So we study the correlation between. So what is correlation? It's like you're trying to say like how similar something is. Like for example, how similar is acousticness to danceability? Like, do they relate? Like, is there any kind of relationship between them? Like, for example, if I tell you that x is 6 times y, then there is a relationship between x and y. They kind of correlate because there is a relationship between them. One can give you the other somehow. Now, why do we need to study this kind of correlations? Okay, so in this case, it's an overkill, but they did it. But usually, you really need to study these relationships when you have, for example, like 5,000 features. Just an example, or even 30 features is too much. So when you have really lots and lots of features, columns, you want to try to find somehow to get rid of some of them. So what are these features usually? These features are what really represents, like what is unique, for example, for each of these songs. Let's say, for example, is something like acousticness unique to a certain song? Can't we trade it for danceability? These are the questions that we try to ask when getting rid of features, like removing them from our data. Like for example, let's say I found out that acousticness is enough as a feature. Like, if I have acousticness, I don't really need danceability because they kind of are the same. I will try to get rid of from one of them. All right, so this is what correlation is all about, why we study correlation and why we need it. But like I told you, in here, it's an overkill because we don't really have lots of features, as you can see. You only have a few. And when they did the correlation, they didn't really find out, a huge correlation. Like the best correlation they find out is this one, approximately 47%. Between valence and danceability. Obviously, it's the same. Valence, danceability in here. So it kind of have a good correlation, but not good enough, seeing as it doesn't, people that have already studied statistics knows that a good correlation is one that is near 1, and a bad correlation is one that is near -1. For now, we won't drop anything. Like all the features are important, so we won't drop any of these. Now, one of the things that you need to do usually when you are, using machine learning models so you can train your data on is to normalize that data. So, let's say, for example, I have a value that is 1 million and I have in my data, it's the same thing, but have different values. So one is 1 million, the other is 0.0000005. As you can see, this is a huge gap. I need to get rid of that gap. To get rid of that gap, we usually normalize the data. So why are they trying to normalize the data here? Because if you look at it, at least from here, it's not really there isn't really there's really a good reason to actually normalize the data, at least here. But they want to normalize it just in case, so they can use what we call PCA, so principal component analysis. Why do they want to use principal component analysis? Remember I told you we usually study correlation so we can get rid of some kind of columns or features, so we don't have lots of columns when we're training our data. This is what they're trying to do. So they want to use principal component analysis to find out what are, like the most meaningful features. I hope you got what actual features are till now, because if you didn't, please ask away so I can explain it again, as it's an important, it's an important concept to get. All right. So what they're trying to do with PCA component, like the principal component analysis, is to try to find out what features are the most important to represent a certain track. Okay, so they will code all of this. So they first, of course, standardize the data. After standardizing the data, they call out the PCA algorithm from sckit-learn. Like all of here, we're just working with sckit-learn. Sckit-learn or scikit-learn is a library used in machine learning, like to get all the machine learning algorithms. You can find all of them in that library. All right, so they fit it into our data. Remember that we normalized the data using this scale, the standard scaler. So we're going to get that normalized data. We're going to calculate the variance. So what is PCA doing? So it's just trying to get all of the, all of these features into one line and try to see if there is a certain way to separate them. If we can separate two features, it means that these features, like they don't really, like we can get rid of them. But if there is, like, for example, if we can't separate, these features, then we can keep that actual feature. But if we can, like, for example, if we can't separate them, like, for example, one is too close to the other, we can confuse them. We can drop one of them. But if we can find a clear line that can go through both of these features, then we need to keep both of them, because both of these are important, as we can do the difference between them, but not like the other ones that we can't find another difference between. So this is kind of what PCA does. But if you're more interested, it will be great. So you can have a look at it. It's highly used, like in all the all the data in machine learning and in all the projects, you will kind of find it everywhere. So it's interesting to have a look at it. So after, after applying PCA, so as you can see here, we don't really know how many features do we need to keep. So what they do is that they try to plot a certain line that can tell us exactly how many features can we keep. Like, for example, here they're trying to draw a dashed line at 90%. So, like, let's say, for example, at 90%, like here, for example, as you can see, is here, like near 5. It means we can keep all of these features, like the first feature, the second one, the third one, the fourth one, the fifth one, and the sixth one. We can keep all of these features because they are important to us. So what they try to find here is the number of features we want to keep. I hope it's understandable. I know it can be confusing. So what they're trying to find, I repeat, is the number of features we want to keep, like the most important ones. Okay. So at the end, what they found out is that they were interested in, like, the most important features that were interesting for our model were 6. I would have actually chosen 5, but I guess they choose 6 because here it's not a clear 5. So they're just on the safe side, they took 6. But actually, like I told you before, in this example, it's an overkill. Like we already have very few columns, like features. So it's not really that needed to get rid of one of them. Okay, so after, like getting the features, telling our model what features are important. Remember here we are doing machine learning, not deep learning. So we tell the model what features are important. After figuring out the features that are important, we're going to train a machine learning model to classify these songs, the tracks, into either the hip hop category or the rock category. Great. So the model we're going to use first is called decision tree. So decision tree is something, it's like an algorithm that goes over the data many times and try to classify them. Like you see here, for example, you have square, you have triangle, but then inside square, we have rotated square, we have straight square. So it's like it classifies, but gradually. All right. Again, we call out sckit-learn, and we call out the decision tree classifier. One more thing I forgot to mention is that in machine learning, you need to split your data into train, tests, sets. All right, so what is the train set? The train set is like it's like the data that is going to be fed to your model so he can learn. So your model knows what the label is. So here, what is our label? It's the genre top, either hip hop or rock. So you tell your model. So for example, I'm just saying, like for example, this song from Britney Spears is actually rock. Okay, so this specific song. And then you tell, for example, another song from, I don't know, from some kind of singer is hip hop. And your model learns. So your model knows what kind of category it is, either hip hop or actual rock in the training set. But in the testing set, you only tell your model, okay, so I have this song and I actually want to know in what category it falls into. So it's like you're asking your actual model to figure out what actual genre a certain music that you are going to give it is. That is why in the test set we will only give it songs and not the genre, because we wanted to figure out what the genre is. All right. So the algorithm that is going to learn is decision tree classifier. It's going to be the one that is going to learn, and it's going to be doing something similar here. So here we don't really have lots of categories. So we only have 2 categories, which are hip hop and of course the rock. Great. Now we ask our model to predict. Remember, predict is figure out, classify, infer. So what we wanted to do is to answer the question. I am going to give it a certain song.
We have a question.
Yes? Did someone say anything?
Sorry to interrupt you. Just we have a question.
We have a question from Muhammad. You hear me?
Yes, please.
Yes,
Muhammad said, so basically we choose the number of features which represents 19% of variances.
Yes.
So here they choose 6.
I think
the number of components they choose is 6.
And 19% of the variance.
Yes.
Okay.
It's 19% of the variance, yes. So this is the variance. This is the calculation of the variance. And this is the 19%, as you can see.
Okay.
So if you drop it, I can't show it to you here, but if there is a line, if you drop it, you will find out it's 5 something. On the safe side, they choose 6 because they don't have much features anyway. They choose 6. But for example, if we had really like lots and lots of features, like let's say, for example, you have 3,000 and they suggested for you to pick 20, I would have picked 20. And not, for example, 10,000. Just an example. Okay?
Okay.
Yes.
But usually, like when there is a huge difference in variance, like, and the data is good, like the quality of the data is good, this line is very straightforward. Like, you will have the exact number. Okay. So after training the model, and we will try to predict, like tell what kind of genre a certain song is from our test set. So after trying to, after asking the model to do his predictions, try to figure out what genre a certain song is, we usually need, obviously, a way to calculate the performance of the model. So there are many different metrics. We will see them down below. And one of these metrics is the accuracy. So practically what the accuracy tells you is like how many of the data that we had or the predictions that the model did are actually correct. Like, for example, he said this song is rock, and in actuality it's rock. So it's going to be a good point in accuracy. Just the question is how accurate your model is, so use accuracy. If you want to know how precise your model is, you will calculate the precision. All right, and obviously these metrics depends on the domain knowledge you're working with. For example, if you're working in a medical field, usually the recall is more important. You're going to see these here. All right. So what you're doing in machine learning is that you don't train only one model because it obviously isn't enough. So you need to try with different models and see how they fare on your data. So some models are going to be better than others, obviously, because each model has its own way to represent the data. So here what they did, they used logistic regression. So logistic regression is the one that is like highly used. Like it's the first one you use. It's similar to linear regression, but it has more parameters. All right. So logistic regression usually used in classification, and linear regression is usually used in regression. Regression is when you have a numerical value, and classification is when you're trying to categorize the data. Okay, so they use the logistic regression method or algorithm from sckit-learn model library. And after training it, so we use fit to train and predict, so we can try to predict what the labels of our tracks here are. So to actually try and see the performance of both the decision tree model classifier and this logistic regression model, they used what we call the classification report from sckit-learn.metrics. So what this classification report provides you is the precision, the recall, F1 score. All of these are metrics that actually calculates the performance of a model. Accuracy is good, but it's not enough. especially when you have unbalanced data. So what do we mean by unbalanced data? Is when, for example, you have like a certain class. Let's say, for example, here, as you can see, we have more data, for example, in rock than in hip hop. So we have more songs in rock than in hip hop. So in this kind of case, the best metric to look into, apart from precision and recall, is the F1 score. So F1 score is a metric that actually can penalize the class that has more data than the other. All right, so for example, here it's going to penalize rock over hip hop. Okay, so as you can see, the performance is similar here for decision tree and logistic regression according to the first two numbers. So usually I prefer to calculate them alone, like not using the classification report, especially when they are very similar, because obviously after the 2 points you can have a difference. Like, for example, we can have a 0.80, like 873 in here and 874. So the subtle differences are very important in machine learning. Great. So as you can see here, like I told you before, we have less data in hip hop than in rock. A question?
Yeah,
Yes.
the question.
Yeah, go on.
Abdelhak said the accuracy is the average or the highest value.
Can you please repeat the question?
The accuracy is the average or the highest value.
The average or the highest value?
Yeah.
I'm not sure I understand your question. Here, are you talking about like what is this? What is average?
I think he means that.
Because the accuracy. Okay, let me pop out the. Let me show you the difference. All of these are just metrics. I mean, they're just you know, like it's math. See. Okay, math. I'm trying to show you the actual equation or how to calculate it, but seems like they don't really want to give us. Okay, so confusion. Correct. Great. So what is accuracy? Okay. I'm trying to see if there is another better example. Okay, there's only sensitivity. All right, no problem. Let's take this one. Anyway, so as you can see here, the accuracy is the true positive plus the true negative over the usually the true positive and the false negative. But seems like here it's a bit messy. Okay, let me just, oh yeah, this one is better. Okay. Okay, so accuracy is true positive plus true negative over the true positive plus true negative plus false positive plus false negative. So what is false positive? What is true negative? And what is all of that? So a true positive is when, for example, I would say, the model predicted that this song is hip hop, okay? And actually, the song is hip hop genre. So this is the true positive. It's a true positive, which means what was predicted is what is actually, like, it's true. All right. Let's say, for example, our model predicted that it's rock, but in reality, it's hip hop. So this is a false negative. All right. Now let's say, for example, it's actually hip hop, but it was predicted as, oh, sorry, I mean, it's actually rock, but it was predicted as hip hop. It's actually rock, but it was predicted as rock, which is good. That is the true negative. And if the model, like for example, mistakes a certain class for another, it's either going to be a false negative or a false positive. Now, the thing with false positive and false negative and all of these things, where do you see the effect? Like, where do you understand them well? Is especially in medical field. Let's say, for example, this is where you understand what is proof positive and what is false negative. So let me give you another example. Let's say we predicted that a woman was actually pregnant, but the woman, oh no, this isn't something that is going to help you remember this. Let's say cancer. Let's say, for example, we predicted that a patient actually had cancer. So in this kind of case, we say that the patient had cancer and they have cancer is true positive. If, for example, we say that, so the patient actually has cancer, but we know that actually the patient has cancer, but we predicted they didn't have cancer. This is actually a false negative. But, and like, why is it a false negative? So false negative is the worst thing you can have. This is the thing that we try to avoid. Why? Because let's say, for example, a patient actually has cancer, but you know your model predicted that they didn't have cancer. That is dangerous for us, because it's okay if a patient doesn't have cancer and you say that patient actually has cancer, because we can still conduct tests and figure out that person actually doesn't have cancer. It's okay. Like, nothing is going to happen to the person. But if we say the 13% doesn't have cancer, but they have cancer and things get complicated later on and they die, so this is really dangerous. So this is kind of what the actual false negative is. And it's really important, especially in the medical field, as I told you before. So overall, the accuracy, just remember that the accuracy is the true positive plus the true negative over the true positive plus the true negative plus the false positive plus the false negative. In simple words, accuracy is what your model got right. Like, your model said that. So we have, remember, how much data did we have before? So we have 4,802, okay? So from this 4,802, if your model, for example, says that, let's say 50% of them are hip hop, and actually all of those 50% are hip hop, then your model is top in performance. The accuracy is going to be 1. Because he got it right. But if he says, for example, that, let's say, for example, only 40% hip hop, and you actually have 50% that are hip hop, then your model is less in performance. So, for example, let's say he has a 10% margin of error. Is it clear? At least a bit.
I think yes.
Yes.
All right. So let's focus on this one. Let's check out precision. Like, let's check out, this. So as you can see here, as I told you before, we have more data in rock than we have in actual hip hop. So here we have a data imbalance. That is why our model, as you can see, is given better results in ROC than in HipHop, either in decision tree or in logistic regression, as you can see. The model has a better performance in ROC data than in HipHop data. Okay. And the accuracy, the overall accuracy of this model is 88%. Remember that I told you that the best one when we have data imbalance is the F1 score. So this is the real true performance of the model, not the accuracy. Because the accuracy, it doesn't really penalize the classes that have much more data than the others. But F1 score does. That is why it is more accurate and better to use when you have a class imbalance. Okay. Now what we're going to do, just to figure out all of this, remember that I told you that we had a problem of data imbalance. So what we're going to do is that we're going to try, to make the data even. So what does that mean? So let's say, for example, I have only 229 tracks that are hip hop. I am going to slice this track. So I only have 229 songs that are in rock, and drop the other rock songs from my data. So I can have classes that are even. They have the same number of songs or tracks. That's what they are doing in here. They are, of course, again doing PCA. We're doing the same thing that we did before, but only on this new data. And we're going to, of course, split the data into train and test. So after this, remember what comes after is training a routine model. So they trained both decision tree and logistic regression. And they calculated again the classification report on both the models as before. And as you can see here, now the performance is better. Or isn't it? I mean, like they are closer. Not before we had a huge difference between them. Like, look at this. Now the model is performing better in both of them. Even though the overall performance has dropped, but still the model is performing better in both classes. So why did the performance drop? It's because we have less data than before. And remember, what is important in machine learning is data. But if you have imbalanced data, it will affect the performance of your model more. So don't go around having more data in some classes and ignore the others. You need to try as much as you can to have data that is even between the classes, so that your model doesn't suffer in a class, in a certain class. Okay. So these are the results of both the models after evening out the data.
I have a question.
Yeah, go.
My first question is, there is just two types of algorithms, classifications and regression.
No, there
is a lot more.
So there is classification, there is regression, there is clustering. Anyway, let me give it a better name. So there is what we call supervised learning, and there is what we call unsupervised learning. In supervised learning, what does supervised learning mean first? So supervised learning is when you have the label. For example, I give you an image of a cat, and I tell the model, this is a cat. This is supervised learning. I am telling the model what is in the data. I'm labeling it. There is the unsupervised learning. In supervised learning, we don't have the label. Like, for example, I only give the model the image, but I don't tell it what is in the image, or what is the image is all about. These are both the huge categories. Great. Now, in supervised learning, there is what we call classification and regression. There are only these two in the supervised learning. In the unsupervised learning, we move on to what we call clustering. As I told you, usually here the data, like we don't know what is the label of the data. So what the model tries to do is to segment, like try to find ensembles that, for example, a certain object is going to fall into. Let's say, for example, what can I do? Let's say, for example, I give you a phone and the charger and the battery, and let's say, for example, I give you fruit. So the charger, the phone, and the battery are going to fall into an ensemble. Like they are the same entity, they're all electronics. And the fruit is going to fall, for example, in the fruit section. All right, so these are the big well-known categories. There is another category that is alone. It's called reinforcement learning. And what reinforcement learning is, for example, when you're trying to teach the machine by rewards or punishment. So, for example, let's say a machine did a certain action and it was a good action, like it did what you wanted it to do. So you will reward it. And if it does something that is bad, as in it didn't do what you wanted it to do, you're going to punish it. This is reinforcement learning. But usually the most well-known are the supervised and supervised learning. I hope that answers your question.
Yeah, and we should have the same amount of data to have a good precision. Does it work only for supervised algorithms or also the other ones?
Usually this kind of thing, actually, what can I tell you? It's normally good to have data that is balanced everywhere. Okay, it's a concept that is everywhere. But is it true? Do we always have the same data? It's not. And sometimes it's good. Like, for example, for example, in real life, we have more healthy people than sick people.
Yeah.
Isn't that the truth?
Yeah.
Yeah, it's a fact. So why do we want to eliminate a fact? It's a good fact.
Yeah,
you see
true.
what I mean? So we can't get rid of that data. Like, we can't lie to the model. We can't tell it, for example, in the planet there are as many sick people as healthy people. We can't.
Yeah, that's true.
You see? So it's like, what can I? It's a trade-off. Like, you as the one, code in your algorithm, choose. Like, what do you want to sacrifice? Performance or reality, for example, or a real fact?
Okay.
You see? So it's a trade-off. You choose. Usually, for example, sometimes we choose to keep it balanced, and sometimes we don't.
Okay.
I think the difference between supervised and unsupervised learning in the data is that in supervised learning we give it labeled data, but in supervised learning we give it just unlabeled data.
That's what I said, but it doesn't answer his question. Like he said, for example, are we obliged to have balanced data in either supervised, unsupervised, or any other criteria?
Yeah.
So he is interested. It's a good question, actually. Like, for example, why should we care if the data is balanced in supervised learning, right?
Okay.
That can be something that can cross your mind. But it's important. Like, it's going to affect the performance of your model. Let's say, for example, you have just like the example I gave you. Like, I gave you only one fruit in the fruit section. and a lot of electronics in the electronics section. You know, like your model may not figure out there is actually another class called fruit.
Yeah, that's true.
You see, he may
Yeah.
even put the fruit in the electronics side because he doesn't have much data to learn from.
Okay.
You see, it's like the humans,
Yeah.
like, you know, when you're with your professor, when the professor does a lot of exercises and give you their solution, you understand better because you have seen all kinds of scenarios. But if for example, he does only one exercise with you, yeah, you will make lots of mistakes when you're trying to do some other exercises. You
That's
see?
true. Yeah, I understand.
We have a question by Hassan.
Yeah, go on.
He said-
I don't
he
think
said,
I'm going to do this section as it's a bit
okay.
advanced. Go on.
Okay. He said, in which case we use supervised and unsupervised learning. If you can give some examples.
Yeah, sure. Okay. I need to give you. Okay. So I'm trying to find out a simple example, not one of the complicated ones. Okay. Let's say, for example, when do we use supervised learning? When you have the label. So when you know what you're trying to detect, to find, or even to predict. Okay, let me give you an example. So you have pictures, okay? And in these pictures, there are dogs and there are cats. And in this picture, you know there is a dog, and this picture, you know there is a cat. So here, both of you know. So you know, as the human, you will label the data. Like, for example, tell it, in this image, I have a dog. In this image, I have a cat. Okay? So you know the label, what the label is. Let's say, for example, I just go around and throw a bunch of data at you. Okay, let's say I give you 1,000, or I don't know, 1,000 is actually very few. 1 billion. Let's say, for example, I give you 1 billion data points. Okay? Is it okay?
It's a lot.
And I tell you to label it. You know, give a name or something to each, for example, image. Are you going to be able to do that? You have 1 billion. It's not impossible, but it will take you a lot of time. So let's say, for example, you want to find out a way so you can, make your work or your job, like to spend less time in it than, for example, if you had to annotate the whole 1 billion. You will, for example, code an algorithm, machine learning algorithm. It's just a simple algorithm that will try to find similarities between these images. Okay? So, for example, your model is going to tell you all of these images, for example, share the same kind of features. All of these images have the same kind of features. You, as a human, you will look, for example, at 10 images from each group, and you will label it later. You see? But the model helped you figure out, you didn't have to go through each image yourself. It helped you figure out, try to find a segment, a group, into which a certain image will fall into. If you ever did business or marketing, you will know that one of the things that we do is segmentation, like customer segmentation. Okay? Let's say, for example, you try to find out what these customers like all of these customers, for example, are women. So this is a group, and all of these customers are men. This is another group. This is something that clustering does, give you groups of people, of things that share the same things. Okay? But it doesn't tell you specifically, of course. He just puts them in a group. He tells you they share the same features. They are all women, or they are all men. Is it clear?
Okay. Yeah, that's clear.
Like the only example I have so far that that is relevant is a bioinformatics example. Like, for example, when we want to try to find out like what kind of chemical reaction or chemical equation, for example, could give us a certain gene or something like that. So in here you have lots and lots and lots of combinations. It's difficult for a human to find it out, like just like that. So we have to test and figure out, like how much research is, especially in chemicals, costs. If you had to try every one of them, how many money do you need? Instead, you could, for example, feed it out to an algorithm, a machine learning algorithm, and tell it to figure out, like just give you a hint. And the algorithm is going to tell you, for example, if we put this with this, it will give you this. Is this example, like, does it give you a clear idea, a better idea?
Yeah, I think so.
Yeah, so.
But actually, classification and regression are the most common. So classification is like here. For example, you have labels, but are categorical labels. Like, for example, we have here hip hop, rock. But in regression, you have a number. You have to figure out a number. Let's say, for example, I want to know the price of a house. So the price of the house, you can ask your algorithm to figure out what the price of the house is going to be according to, for example, the number of rooms, where it is located and all of that. So this is regression. And if I tell it, for example, I give it an image or even features and I tell it, is this a house? Is this a bungalow? Is this a villa? So this is classification.
Okay.
So Adil, he said, is it necessary to use Python for machine learning, or you can just use any other programming language?
Without any difficulties?
Any difficulties?
That's a lie. Okay. So there are languages you can use like Java, C++, and even R. But the thing about these libraries is, about these languages is that there aren't lots of libraries like Python. So Python has more libraries because, it's all about contributions. There are more people that knows how to use Python and contribute, in machine learning by using Python. Not like the other languages. That is the difference. But all the languages can obviously code machine learning algorithms. I remember, there's just a bunch of math.
Okay. But I think that Python is faster, no? Than the other languages. Like
What? No. The most performant one is C++. It's well known.
Okay.
Yeah,
Okay.
for example, when you're doing computer vision, let me give you an example. When you're doing something in computer vision, the self-driving cars example. So what they do is they code the machine learning algorithm in Python when they're just trying it. And later, they transform that code, when they optimize it and all, they transform it into C++ and use it in the embedded systems so they can embed it in the car.
Okay. Okay.
Because C++ is faster. Yeah. It's all about memory management, computation resources management.
Okay. There is another question.
Yeah,
okay.
There's Hudayfa, he said, what does the random state parameter means?
That is the hardest question you can ever ask. Because I still haven't figured out like what it really, really, really means. But usually what the random state help us do is to remember, like the parameters and the state, whatever we did in the code. It's just so, for example, for me, I got 90% when I trained the model on my data. If I use a random state, like for example, 0, and I give my notebook to you, and you run it, you will get the same result. But if you don't input the random state, you won't be getting the same results, even though it's the same data.
Okay.
Yeah, this is what the random state is for. Seed. There is something called seed, random state. There are a bunch of other things they give it as a name, but it all points to the same thing. It's just so we can replicate the results. That's it.
Okay.
It doesn't have any special meaning. It's just to remember a technique. Let's say, for example, I used some kind of technique, special techniques to, like split the data. I will remember that technique. The code will remember that technique, so they can replicate it. Is it a bit clear?
Yeah.
I hope it's less confusing. Let's say, for example, I'm just going to give you. Let's give this example. So when I split the data, I used the shuffle method. So what is shuffle? Let's say, for example, I shuffled by, for example, like switching places. Like, for example, I put the first row as the second row and an example like that. Okay. So I used this technique. Like I only switched the places of the columns. Like the last one is the first one and all of that. So this is the method. So for example, if I give my notebook to you, Hudayfa, and you run that notebook, scikit-learn is going to remember that, it's not remember, but like they know that what the way they used to split the data in this, in this notebook is actually by, for example, switching that second column as the first one and all of that. So you can get the same results later. I hope it's clear.
I think so.
For me.
Yeah.
So Hassan, he said that Google Photos, you supervise algorithms or unsupervised to your group image, like image that are selfies.
It depends on them. They can use both. You can use both, and I think some of them use the actual supervised ones, and some others use this unsupervised. Let's say, for example, there isn't a clear label, like I told you before. Like, for example, they want to regroup. Like, they have never seen these images, and they want to find some kind of grouping. So they will use unsupervised. But if they know the label, like, for example, there is a dog there, there is a cat, so it's something that is well known by everyone. So they will put it in that category. But if it's something new, never seen, like, for example, picture of somewhere or picture of an object you created, they won't know about it. Like, they don't know what it is. They will try to figure out, of course, what category it falls into, but it's going to be using supervised learning because it has never been seen. They will try to find out, like what kind of group it can fall into. Is it a painting? Is it something like that? But they won't know like the specific category. So it's unsupervised learning.
So I mean, is it he needs some explanation about tree decision?
What do you want to know about decision tree? Like I told you, it's just an algorithm that is based on the tree. A tree ones, like, for example, you have what we call a node, and they will try to have smaller nodes, like, for example, okay, let's say, for example, I have fruit. Okay, fruit is a broad category. Yeah. You can have bananas, you can have any kind of fruits, like, for example, ananas, something like that, alone as a category. So fruit is the general one. So it's the node, the one that you will have first. And later on, it can split it into two categories. Let's say, for example, you will have the, what do we call it? Like, for example, let's say I'm beginning to forget things. What kind of fruits do we have? Okay, so let's say, for example, bananas here in a section, and then, for example, it's going to split them into... I'm beginning to forget what kind of fruits are in English. Help me out. Oh, apple. Thank you.
Yeah.
So we'll have, for example, that data splits into apples and bananas. So we have here, this is another splits, and it's a tree. You know, like we have the top, which is fruit, and then the down, which are the bananas and the apple. Okay. So for example, we can have another section from the apples or the bananas, like say, for example, one from Africa, one from America, something like that. This is how the decision tree works. But of course, you already have the labels defined.
Okay.
Okay. So I think that's it. But I have a question.
Mm-hmm.
Is that data science? Is it a subset of AI, or just it use AI and machine learning?
Data science uses all of them. It uses big data engineering, it uses machine learning, it uses deep learning. You just use whatever you have according to the situation that you have.
Mm-hmm.
I think the question of Amin, he said, I understand tree decision, mathematic, but when I want, but how I can implement it in Python?
Use sckit-learn. Why do you want to implement it? Or do you want to implement it from scratch? Like, what do you want? If you want to implement it from scratch, use NumPy. Otherwise, you can just use the library already available from scikit-learn.
Scikit what?
Scikit-learn.
Okay.
Let me write it for you. Scikit-learn. Yeah, this one.
Okay.
Or sklearn. Even like sklearn or scikit-learn, whatever you want.
Okay.
Okay, I know. Then what do you need? You can use NumPy, yes. Yes, you can use NumPy to code this from scratch. You can just search online. I think there are lots of algorithms being implemented from scratch. I know that SVM has been implemented from scratch. So you can just search for it. There are lots of resources online. If you want to use NumPy, please search for it. Like if you don't know how, usually the best thing to do is to check out, like, check out the algorithm, the maths and all of that, and try to code it from scratch using NumPy, using just your, just what you understood. If you fail at it, you can look out at how people did it. Even sklearn, you can even check out how scikit-learn did it. Like how did they code it? Because the source code is available. It's an open source library. You can check out how they coded it and do similar things.
So can you tell us about future of AI in Morocco?
We just started. Well, they're trying their best to implement it, but I think it's going to take more time. Like, what do you want to know exactly in the future of futures? Because anyway, in research, there are lots of researchers in Morocco researching using AI, of course.
Yeah.
It is active. We have active research in Morocco. But obviously nothing interesting, like coming up with new algorithms, coming up with, new data, like ImageNet or something like that. It's not because we can't, but because we don't have the data and we don't have the money to train those networks. In research, of course. But in practice, they say they want to, they say they want you to use an AI. But it's at the end they will just code it from, just code it using something simple, nothing AI-ish. Because they need the data. We don't have the data. They need data, but we don't have it. That is the huge roadblock.
Is it hard to get data?
What do you think?
No.
I think the hardest thing in the machine learning is data. It's getting data.
Yeah, it's getting data. Everyone knows that.
Okay.
If you want data, you will need to store it.
Okay.
Right?
Yeah, that's true.
And the store, okay, how much do you need computing power? There are lots of things you need to think about. How do you collect that data? From where? Which format? There are lots of questions they need to answer, and they don't want to answer that because we don't have money. You don't use machine learning just because you want to use it. You need to use machine learning if it's going to add value to your business, because machine learning isn't easy to implement. Like, for example, one prediction can take like 1 second. 1 second is too much.
Yeah.
If you want to reduce the number it is taking, you need a lot of computing power. From where are you going to get that computing power? You need servers.
Yeah.
You see? It's a problem.
So Rashid, he said what is end-to-end model?
Oh, an end-to-end model is the one where you use 100% machine learning or 100% deep learning algorithms. That is an end-to-end model.
Yeah, I understand.
Let's say, for example, you will use SVM for classification, and then later on you will use logistic regression. This is a machine learning model, end-to-end model. If you're going, for example, to use, let's say, CNN, and then later on you will use, for example, a variant of CNN like ResNet or something, this is an end-to-end model in deep learning. But if you use SVM, for example, with CNN, this is a hybrid model because you use something from machine learning and you use something from deep learning. The main experts will be, the main experts right now are learning data science, just to let you know. All the medical people are learning data science. How do you think domain knowledge will affect on data scientists in the future? Why are you talking about the future? Domain expertise is needed right now. If you have domain expertise and learn data science, you are better than a data scientist that have no knowledge, no domain knowledge. But if you're a data scientist, a good one, and you have a domain knowledge, you're the perfect data scientist for that business or that domain, because you have both of things from the good word. Quelle est la valeur minimale en loss accuracy qu'il décide de modèle est performant? It depends on the model. Bien sûr, pour loss, la meilleure loss, c'est celle qui tend vers 0. Et la meilleure accuracy, c'est celle qui tend vers 1. Donc, quelle est la plus performante? Ça va dépendre de la qualité de tes données. La qualité de tes données, ça va être tout to pick the actual decision.
Okay.
I think it's clear. Can I ask you one other question?
Yeah, go on.
What is overfitting?
Overfitting? Yeah. What do you want about overfitting?
What is the problem of overfitting?
What is
Machine learning. Overfitting. What is it?
You mean what it is?
What it is.
Oh yeah. So overfitting is when your model learns only what is in the training data. Like it doesn't generalize well. Like for example, if you give it some data it has never seen, it won't be able to perform as well as when it did when it was training on the trained data. That is overfitting. And underfitting is when your data is when your model is given the worst performance in the world. It's not knowing anything. It doesn't know anything. قمار أحسن منه. Oh, قمار is someone that is gambling. A gambler is better than a machine learning model that underfits.
Do we have other questions?
I think no, that's it.
Okay.
I hope the example wasn't complicated.
No, we understood.
Because like there were lots of things that needed to be explained. When you finish, please post the slides and learning resources. Okay, I will share the slides with you and you can check out all the resources that there are. Like all the things I have, even the pictures, like for example, if I post a picture, it's clickable. So you can check out the resource.
Okay.
Washington is best loss for graph CNN. Wow. I never heard of this. I guess I'm going to research for it. I am going to see if there is a Washington loss. I never heard of it. I have been coding CNS for a while now. Graph CNN. Oh, I have no. I have actually never tried graph CNNs right now. But I will. I mean, I think I'm gonna like have a look at graph networks in general later. But like, it's not something of interest to me right now.
I need an advice. Now I'm in beginning of learning machine learning, and I don't know what type of certifications I should get or I should work for to get them.
Don't try to get certification. Try to get knowledge. Certifications don't have much value right now. Because everyone is getting certifications everywhere. So, like trying to learn and practice. If you can have, something that you did from, like from scratch, that is yours, and that is obviously have been done before, it will be better. That has more value than a certification for a recruiter, at least.
Okay.
Okay, suppose we have small data, say like, can we make an effective machine learning model out of it? It's the only data available and only slowly growing. Yeah, 500 is decent. And 1,500 is decent. You can make a good machine learning model from it. Just make sure to clean your data well so that it doesn't affect your performance. When can we use the data generator module? Each time you have, usually each time you have textual data and image data, use data generator. Usually this is the cases where we use it. But you can use it whenever you want. There are data generators for tabular data, image data, textual data, audio data. Just search for the one you need in the library you are using, either PyTorch, TensorFlow, or some other library. Always check out the documentation. Documentation is your best friend. You're welcome, Hudayfa. Oh, hello, Abderrahim.
Hello.
Hello, Ibrahim.
جبت لنا شي كيستيون ولا جيتي خاوي؟ What are the precautions that should be done when you cannot afford to classify wrongly? Okay. So in this kind of case, try to get a good recall. Remember that only one metric isn't enough. The best way to really, measure the performance of your model is to calculate the precision, recall, F1 score, the accuracy, try out area under the curve, and use the cross-validation method to train your data lots of times, so you can figure out if the performance that is being reported is the real one.
So I think that's it.
All right.
So thank you for being with us today.
Thank you very much.
Thank you for inviting me.
Really appreciate that.
Thank you. And I hope you'll actually learn something.
Yeah, we learn a
Thank you
lot.
very much. We learn a lot.
Now we have a good vision to continue. Thank you.
That is great. I'm happy to hear that.